All right, welcome everybody. In this video, I want to keep on working with the pivot longer function that we've been working with from the tidyr package. We've been working with some examples with smaller data frames to just really illustrate the idea of what it means to pivot, what it means to lengthen data, since these are probably new concepts. So we've been working with small data sets for tuberculosis and population data. But now I want to kind of implement this in a really large data set and really drive home the power of these functions. So these tables that we've been working with earlier, they are based on data from the World Health Organization, a tuberculosis global report that came out recently. And so the full data set has like over 7,000 observations and 60 variables. So it's a very large data frame. And in order for the code cells to run below, just be sure that you run the library tidyverse command to install or to load the packages that you're going to need for this data frame. And so if you have any, if you're curious about this data set that we're going to work with in this video, the data frame is WHO2, which is World Health Organization 2. This will bring up help documentation for it, where you can kind of read about where the data comes from and what are the variables inside of the data frame. But I'll summarize that for you here. We can run a print command and notice that this is a tibble. We can see how many observations there are and how many variables there are in the data frame. And so this is actually, this says there are 60 variables in the data frame. I think there are actually 58 variables in the data frame. Okay, so we've got country, and then for each country, we've got a whole range of years from 1980 up to, we can actually see exactly how many years worth of data. So for Afghanistan, the data goes from 1980 up to 2013. Then it goes to Albania and so on. So for each country, we've got data for a whole number of years. For some of those years, there are missing values. They might not have been recorded up to a certain point in time. And then we've got these column names over here, which have some weird codes in them. But we actually get a lot of information from the way the column names are coded. So that's what the point is going to be here, is how can we pivot and get data, how can we get information values from the column names that we have up top? So let me explain how what information is encoded in these codes. So there are kind of a first section. This SP is telling us something about the method of diagnosis for tuberculosis. Then we have an underscore, and then we have an M or an F to indicate the gender. Then we have an underscore, and then we have some numbers that are indicating an age group. So for example, this first column, SP underscore M underscore 014, is telling me the method of diagnosis, SP, was a positive pulmonary smear for you tuberculosis experts out there. This is telling me that this data is corresponding to males only. And the 014 is telling me that this is corresponding to the age group 0 to 14 years of age. So here we're getting a count for the number of males age 0 to 14 that got a positive pulmonary smear and so on. So you can see there are a whole bunch of variables that are encoded the same way. So this is 15 to 24-year olds, 25 to 34-year-old males, and so on. We have similar variables for females of different age groups and for different methods of diagnosis. So there were negative tests, there were relapses, there were extrapulmonary and other methods for diagnosis. So here, what I want to do is, if you're thinking about how could we tidy up this data frame, well, maybe if I'm thinking about this data frame, the variables in this data frame could be country, could be year. So those are already set up nicely. Then I could think of method as a variable, right? These were all different methods. I've got 1, 2, 3, 4. So this is like a categorical variable. I can think of gender as a categorical variable, and we had two classes that were included in this data frame for male and female. We have age, which in this case is also being stored as a categorical variable. We have different age groups, 0 to 14, 15 to 24, and so on. And then we have a number of tuberculosis cases that were identified in each of those groups. And the way that we can extract this information, so we're going to lengthen the data frame considerably, right? So we're going to take lots of each of these columns is going to be lengthened. So we're going to kind of take each of these columns and we're going to split it into multiple rows. We're going to create a number of rows from it. And the way that we're going to do it is from one column, we're going to get the method from the first prefix. And then we've got an underscore. And then we get the gender after that first underscore. And then we have another underscore. And then we're going to get the class for the age after the second underscore. And then we're going to get the values for the number of cases. We're going to get that from the value in the column. So let's see how we could code that up nicely using the pivot longer command. We're going to add a new argument to the pivot longer function that we didn't use earlier, which is called names separate. And so there are some additional arguments in pivot longer that we haven't discussed. So you can run a question mark pivot longer to get under the hood of that function to see some of these additional options. So the data that I want to clean up is the World Health Organization 2 data, the WHO2 data set. So I'm going to input that into the pivot longer function. Which columns am I going to want to pivot longer? It's going to be everything except for the columns between country and year. So here was country, here was year. It's really just the two of them. So these two columns, I don't want to do anything to, but all of the rest of the columns, I am going to do this to. So that was just a simpler way of indicating I want to gather tons of columns. So it was just easier for me to indicate which columns am I not doing anything to. So this is just saying the only columns were the columns that we're gathering are not country and year. So every other column we are going to gather together. So I can use like the not logical operator to indicate which columns I want to combine or gather in this case. So actually what I'm doing here, if you think about it, is I'm combining all of these columns together, all of them into one column that's going to be called cases. Okay, so I'm combining like, 56 columns together into one column. So I'm combining everything, all of the columns other than country and year are going to get crunched together into one column that I'm going to call cases down here. Okay, otherwise, each of these other columns we're going to use to create some additional columns. So we're going to indicate where did this value come from by saying the method we're going to get from the start of the column name. So I'm going to use this to specify the method. So I'm going to create a column that's called method, and it's just going to pull off the first, whatever comes before the separator, that's going to be listed in the method column. Then I'm going to create another column called gender, and it's going to pull off whatever comes after that first separator, which is going to be an M or an F. Then we're going to create a third column that we call age, and it's going to pull off whatever comes after the next separator, and that's going to be the value in the age column. And then whatever values are in this or were in the original column, they're all going to be gathered together in one column that we then call cases. So that's what is being indicated down here. So we're going to gather together all of the columns other than country and year. We're going to create a method column that's going to pull off that first prefix. We're going to create a gender column, which is going to pull off the letter M or F that comes after the first column separator. We're going to create an age column that's going to pull off the age group that comes after the next column separator. And then finally, all of the values are going to be moved into a single column that we call cases. And now, rather than like print the entire data frame, which is going to now have an insane amount of rows, because we're going to make this in way, way longer. We already started with 7,000 rows. Now it's going to have way more rows. I'm going to do the enhanced print so we get a nicer printout. You can see now we went from 7,000 rows to like 405,000 rows, but we only have 6 variables. And this is actually way nicer organized data than what we started with over here, with all of these like weirdly named variables that were all measuring really the same thing, which is tuberculosis cases and how they were diagnosed. So here we've got country, we've got year, we've got the method of diagnosis, we've got gender as a variable, we've got age group as a variable, and here we've got cases. And we could rename these as we want. These are being stored as characters. There's additional cleaning up that we would want to do here, right? We could store these characters as factors. We could remove missing values if we wanted to. So there is additional cleaning that we can do at this stage, but at least we've now stored the data in a tidy fashion. So that was a really nice way of tidying up a really large data set in really like small, nice, concise code. Super nice. Okay, so that's a wrap on pivot longer. There are all sorts of other things you could do with this function. I just wanted to illustrate kind of a basic example and then a more complicated example. And next, we'll take a look at what it means to widen data frames, which is a totally different operation. And then we'll play around with that a little bit. Thanks, everyone.